Any way you look at it, this is very interesting weather. Well, now that we've discussed basic weather theory, including winds and clouds, let's combine it all together and discuss weather patterns. We'll start with the stability of the atmosphere and what affects it. And this knowledge will help you determine what types of clouds you'll see and what the visibility is likely to be. As you remember, hot air is lighter than cold air, and as a result, air that is hotter than the surrounding air rises. Anytime the air above is colder than standard, air that for some reason is lifted will be warmer than the surrounding air, and the lifted air will continue to rise. Now, this condition is referred to as an unstable atmosphere. So how do you determine the stability of the atmosphere? Well, what you do is you measure the actual lapse rate, the decrease of temperature with altitude, against the standard lapse rate. Now, the standard lapse rate is a decrease of about 2 degrees Celsius for each 1,000 feet that you go up in altitude. If the temperature gets colder more quickly than standard, you'll have unstable air. However, if the air gets warmer with altitude, or gets colder more slowly than normal, then you've got stable air. Obviously then, temperature affects the stability of the atmosphere. But another factor that affects stability is moisture. Since water vapor is lighter than air, when it's added to the atmosphere, the air's density is decreased and it begins to rise. So adding moisture to the air decreases stability. On the other hand, when moisture is removed from the atmosphere, the density of the air increases and it starts to settle. So removing moisture increases the stability of the air. Now let's assume that you've got stable air and it's moving up a slope. What kind of clouds would you find? Well, stable air resists rising. So when it reaches the top of the mountain, what it will do is level off and remain at that altitude. And the type of clouds that form will be stratus type of clouds. And if there's any precipitation, it will tend to be steady precipitation because the air is not moving much. And the air will be smooth typically with very little turbulence. But let's assume that you're flying over a desert where it truly gets hot. The air above the desert is heated from below, creating rising columns of air called thermals. That rising air will be warmer than the surrounding air and will continue to rise. And this is called unstable air. So what kind of weather do you get in unstable air? You tend to get turbulence, but you also tend to get relatively good surface visibilities because that rising air carries away the pollution and haze in the lower atmosphere. Now, in a moist, unstable air mass, the type of clouds that you'll get will be cumulus-type clouds, which are usually accompanied by showery precipitation because the air moves the clouds along. Now, let's assume that an unstable air mass is forced up a slope. What kind of clouds are you going to get? Unstable air tends to keep on rising, and what it will do is produce clouds with a lot of vertical development. And when you get towering cumulus clouds, those are going to indicate convective turbulence. If you add lots of moisture to unstable air, now life really gets interesting, and here's why. As air is lifted, say by heating of the Earth's surface by the sun, it rises to an area of less pressure and it expands. Now, when air expands, it cools. Cold air cannot hold as much moisture. So if the air had lots of moisture in it to begin with, it will condense and form water droplets. Now, when the water condenses, it gives off the heat that it took to make it evaporate. It's the absorption of heat for evaporation that cools your moist forehead on a hot day. So when the water droplets form, what is called the heat of condensation is given off. This heats the air up again, and the air will rise. And as it rises, it expands and it cools. Cold air can't hold as much water, so water condenses. When the water condenses, the heat of condensation is given off. That heats the air, and hot air rises. And as you can see, the air will keep on rising as this cycle keeps repeating itself until the air either runs out of moisture or until it is no longer warmer than the surrounding air, which usually happens at the tropopause. And that, folks, is how a thunderstorm forms. Convection is rising air, and the ultimate in rising air is big, towering cumulus clouds, which may eventually grow into thunderstorm clouds. So to pull it all together, when air near the ground is hot and moist, suspect a bumpy ride and showery kind of precipitation, which may go a long way in explaining why, when you're flying over the nation's capital, the air is usually unstable. You've got all that moist, hot air being belched into the atmosphere by armies of politicians.